Another Bevy version. So 0.15. If anyone's been watching the channel, they've actually noticed that I've been using 0.15 for a few weeks now and messing around with it, doing live streams and stuff. That's because they've changed to a pre-release cycle or a release candidate cycle, I think it's called, where they release to crates.io with like -rc, and then people are able to like port their code using a release candidate copy, and then when the final drop comes, it means that you don't have to wait ages for all the plugins that you used to port. Depressingly, it meant that a lot of plugins weren't getting ported because they just weren't porting to RC, but they're probably already updated now just because like they've got teams behind them. They just weren't pushing pre-release copies out. But Bevy 0.15, absolutely massive update. Sadly, it doesn't add some of the really cool stuff like an editor yet, but it does do some pretty incredible things like the required components that push the editor much closer into our feasible point. And there's also something, I think it's called like remote access, Bevy remote protocol, which allows for you to send like HTTP requests to your game and have it respond with like the information. Like you can request the components on a specific entity or like the transform data of a specific entity and get it back, which means that you can make editors that can then change the game remotely, which hopefully with the fact that you can add and remove components and all that will mean that things like Bevy Editor Please, the third-party plugins, will get hugely improved by the fact that I think Bevy Editor Please had a limitation of you had to hard code every single possible bundle you wanted to add. Bundles aren't a thing anymore, for one, but well, they are, but like they're reduced to require components. So you can still use a bundle, but Bevy itself is deprecating bundles. But the remote protocol will be able to do all sorts of things. Like you can specifically add individual components without needing to hard code in a specific function to add that component. You just need the name and the required component data. Anyway, to get started, 0.15. So first thing they added was the required components. This is something that I think I personally suggested like years ago when I was trying to do something to do with serialization, and I was like, hey, it's really annoying that when I serialize a scene, it also takes the global transform and the computed visibility, which I don't think was a thing at the time, but like the visibility, maybe the inherited visibility, that would like all get serialized, that you then needed to deserialize back into place, when in reality you could just drop the default value in because Bevy computes these values every frame anyway. Like anytime the transform changes, the global transform is updated. You can reconstruct the global transform purely by just having the transforms of everything in the hierarchy. So I suggested doing this, not drive bundle, where is it? It's the like doing something like saying when you derive component, can you derive like required additional components? So that's what they've done, is you can require like that it needs a team and a sprite, and then the sprite requires transform and visibility, and all this allows for removal of bundles. So in Bevy 0.14 and previous, you needed to provide a bundle which contained all of the components that you needed to get that behavior to function. So the player bundle contains like the marker struct for a player, or in this case the player's got a name, but and like the team that they're on, and then that it had a sprite, and then it had a transform and a global transform and a visibility. Like it had to include everything, and it didn't nest hierarchically, which means, or like didn't inherit the inherits. So you couldn't just add a sprite bundle. You needed to add a transform and a global transform and all like the dependents of the dependents. So you couldn't just chuck a transform on, because transforms don't work if you don't have a global transform. Required gets rid of this because you now state that a transform requires a global transform, and then any functionality that you do works. It also means that because global transforms work on a scale beyond transforms, you can just add a global transform if you don't necessarily want the hierarchy of a transform, whereas a transform will always require global because it needs to know its position relative to its parents. So this is a huge improvement for making like bundles much cleaner and more obvious. So like I've been doing it again on stream, where I made a pathfinding algorithm where you just attach a pathfinding component, like the target, and it would automatically add the path that it's going to take, the next cell that it was moving to, the previous cell that it was coming from. All those components were added on. You didn't need to make a bundle that then included everything. Literally just saying target that, and all the pathfinding logic would work. Whereas with bundles, if you didn't attach the whole bundle, you may have been missing components that would be required to functionally operate. Whereas now it's like this thing needs all these other things, automatically adds them. They've also got constructors, somewhere down here. So at the moment, it will complain if you don't have default, but you can provide somewhere like a function that derives the result. So in this case, it will call blue team whenever it goes to insert this, and that just returns the blue team. Or you can use a capture or closure and then just, you know, say like blue team, and it'll just return that. So amazing stuff. They have a section here talking about like how is this not object-oriented inheritance, and they point out that the difference between this and inheritance is this is a relationship of has, not is. So a button has a node, but well, in this case they're saying is a node, but it has all the components of a node, but it itself is not necessarily a node. So the functionality can change dramatically without needing to custom write anything. And you end up with the ability to attach components on top, whereas with object-oriented stuff, you can't do that because inheritance is a straight line. Each thing inherits from its parent all the previous baggage that comes with it, which this would also do, in that any required components of any components you require are also required, but you can also add a whole bunch of other stuff without necessarily changing what you are. So there's lots that happens with this. They have a brief section talking about how bundles aren't going away, because technically speaking, anytime you insert anything, it has to be a bundle. Like tuples of components are bundles, which is just a regular structure in Bevy. But Bevy has deprecated all their built-in bundles, which has led to some really annoying stuff porting things, because lots of like the PBR bundle, because they've kept the bundle but deprecated it, you needed to wrap the handles inside the component that replaced the bundle inside the bundle, which again, if I just remove the whole bundle entirely, it wouldn't be a problem. But it does lead to some really clunky looking code at the moment as the transition happens. And I think the next version, they're going to get rid of bundles entirely. So it's just deprecated for one version so that porting isn't such of a headache. There's another thing that they talk about. I think it's the rendering scenes. When they load stuff from the render world, they're apparently doing a lot of janky stuff at the moment, purely about making sure that when you're porting, it doesn't cause as much of a headache. And then when everyone presumably is ported to 0.15, they'll remove a lot of that stuff so that it works properly. They've overhauled like a lot of the UI related stuff to this as well. So in this case, they're talking about node bundles. So originally you had a style component. That's all been taken off and put inside of node, because their functionality is if you're a node, you need to know your style, and then this will allow for a better inheritance of style and stuff like that. It also comes from a section there they talk about like the approach you should take when designing a component. I think it might be this section. They talk about like each component should have all of the stuff around like a concept. So the player should contain everything the player needs, and you should only split them off into separate components if for performance reasons, like something's getting read by a lot of different things, or like mutable. Like a specific section is always being borrowed mutably, but other section isn't. So you should split that off. Or if you, for example, like, is it like if they talk about like using it, like the parts of your component, the concept component, so like in this case, the player, should be all your public API equivalent stuff. So things that people that are requesting player may need to know, and the private fields or implementation details should be their own component sort of thing. So that's sort of the structure that they've taken with the new stuff, as opposed to before where it was a lot of this data is all related to itself, so it's a component, and now it's the node is all the node related stuff, and they split out all the stuff that Bevy computes, and that's its own computed node, and the stuff that you set is in node, so that like the public interface and the private interface are two separate components, but everything's been bundled into a singular component for you to interact with. So there's, of course, they've done the same kind of thing with text, where before you needed to do like a whole nested data structure of text, and then like the text style, and then a different piece of text and a different text style. Now text is just a wrapper around a string, and then there is a text style that you can add, and I believe it's if the component doesn't have the style, or if the entity doesn't have a style, it'll use its parent style. So this means that you can sort of nest strings down, so like text font, text color, text layout, and it allows for like with children, or just spawning a root and then adding children. So it can have a much more dynamic ECS style of laying things out, whereas before you had to know what index in the array your piece of text that you were trying to edit was. Now you can use like a marker struct to find a specific piece of text, or you can use a name component to mark a specific entity as being a particular piece of text. So they've made text a lot more flexible. A lot of this section is kind of boring stuff because they're just talking about how different things have changed, like how sprite, you just say sprite image default, and the visibility and that will all be added automatically. Same with how visibility adds global transforms, and transform adds global transform, visibility adds inherited visibility, view visibility. Cameras are now much easier to spawn because the 2D and 3D cameras are just components. I think it's either the 2D or 3D is just a marker struct, like literally it contains no data, and then everything else is added, like the camera and the frustum. And this adds a lot to the flexibility because it means that they can do things like, they talk about motion blur is now its own component. So instead of having like a camera that contains like a toggle, it's like if you stick a 3D camera on and then stick a motion blur component on, the motion blur can now like be a marker struct, and then all of the required components such as depth pre-processing and that can be added just automatically instead of having to have a whole bundle of stuff that you may need to configure, or pieces that may be overwritten, as in like if you spawn a default camera, it may load something that then adding the motion blur would overwrite. And the idea being that if you've already configured it in the camera, adding the motion blur shouldn't override it. So the required components mean that you don't have conflicting bundle implementations where two bundles both require something, but both bundles need to be added. I talk about meshes. So meshes have changed from just attaching a handle to wrapping the handle and saying it's a mesh 3D and a mesh material 3D, and obviously the 2D equivalents, which does in theory mean that you could have a 3D and a 2D world have some kind of weird interaction of you're rendering a 2D mesh and a 3D mesh, but they're the same entity, so the transforms are linked together. I was talking to someone about doing like a physics-based game where like the physics engine is running in 3 dimensions, but the world is only in 2 dimensions, or the physics is in 2 dimensions and the world is in 3 dimensions. So you can move up and down a wall all you like, but you can't pass through the wall, or you can't walk around it because on the 2-dimensional plane you are colliding with it. And other kind of interesting things that you can do, because you could have a 2D object and a 3D object share a transform but actually be rendered completely independently. So there's some interesting stuff that you can do there. Lighting is another thing that's been like sort of simplified away in that all the implementation details are hidden behind a required components, and only the information relevant to actually setting up a light bulb is included inside the struct instead of being a bundle that contains all these extra pieces. They've changed volumetric fog scenes, which have like a weird, there's scene root and then dynamic scene root instead of attaching a scene handle and dynamic scene handle. Again, it's a lot of the same stuff. Audio players, instead of attaching the handle, you have to put it in an audio player. Apparently it's all IDE integrated, which is, like, again, it's something I've been loving just playing around with this in live streams. Is if I hit F12 on a required component, it'll actually automatically take me to the definition. Like, it does detect that they are structs and not just random pieces of text that are passed later. Okay, what's next? So the next thing is the runtime requirement components. So in Rust, there's a thing called the orphan rule, which basically says that if you don't own the trait that you're implementing, or the type that you're implementing it on, you can't implement it. So that means that you can't require a specific component on a type that's not your own. Like, you can't say that Bevy's transform now requires an additional trait because you're implementing some kind of logic. Then so they've added a way of at runtime requiring additional, like, well, not runtime, but like when you build your application, you can say that you want to require, in this case, all birds to have wings, because what this implies is that you didn't implement birds, but you're adding a wing struct that does something. And then there's also a with, which allows you to pass in a constructor as well. So you could customize how it goes about it, but that's not entirely relevant for how this works. But yeah, the idea being that when you implement bird, you want it to have wings, but you may not be the original crate that implemented birds. The example they give is physics plugins. You may want to say that all transforms need this extra piece of information, but because you don't own transform, you can't do that. But you could say that when they add the plugin, the physics world plugin, it automatically registers that like transform has some additional thing that you don't have access to. And there also, you can only ever add, you can't remove. And the idea behind that is if a crate has said it's a requirement, then they are assuming that every single instance of that struct that component will have these additional components. So it would make no sense for you to add a crate on top that then takes those away. So this is purely an additive functionality. So chromatic aberration, which looks amazing, is just another like default feature that Bevy now has that cameras can have, I believe. Visual bitmask ambient occlusion, which ambient occlusion is like lighting around corners and like shadows of things where it's like they're lit from not the direction of the light. So in the example here, the light source coming through the windows is lighting the tops of the desks and the sides of the desk, but in reality, light would bounce off the back and light up underneath them, causing shadows below, and that's what this is. So it gives much more crisper lines, stuff, and it's just like another algorithm for doing it compared to other like algorithms that Bevy has for ambient occlusion, and can just make lighting really interesting. I think it's probably something I should turn on my voxel game, because it would make like blocks much easier to distinguish. But anyway, volumetric fog is now supported for point lights and spotlights, which I believe it was only directional lights before now, but now it's obviously implemented. There's also fog volume. So this is a way of saying like only a specific part of the world, like you could have like a sphere around a certain object has fog, and then only then gets rid of volumetric fog. It also allows for 3D textures. So in this particular example here, they have the fog changing as they move this, like slide the 3D texture through the world. So you can have like really dynamic fog, which I'm not sure if this is a fog volume that this is, or a 3D texture, the rabbit. But the idea being that you can have fog that is a much more fine controlled about where the fog is actually placed, instead of it just being a distance from camera fog, and you can control it more. Order independent transparency. I can't really tell the difference between these two pictures looking at them. Like, this is one of those. It would probably be really important for certain video styles. I think this one here is having like flicker in here, where it's changing the order at which what transparent layers, like which are multiplied or added first. So you can get like a different look depending on like what angle Bevy decides to render things in. So order independent transparency is a way of applying the transparency so that it doesn't matter which one's on top, you get the same color, and just kind of cool. User-friendly CPU drawing. So this is something, again, like if you've watched any of my live streams where I fuck around with textures, it's amazing is that they've made it much easier to sort of dynamically create textures like at runtime without needing to like know all the internal structure of the texture. So in this case, they're creating a UAS RGB texture that's 64 pixels by 64 pixels. And then they've added some helper functions. So you can say set color at, and then to provide like the pixel locations and a color, and it'll just automatically work out how to convert this color space into this color space, and then set the pixel at the correct offset to be at that on the screen. And so you don't need to worry about the size of the pixels and how many bytes each pixel takes up. You can just specify 23 pixels across, 32 pixels down. I want that pixel to be this color. And then there's also set color at. You can use the fancy color scale. So in this particular case, that is the value that you'd be setting in there, whereas this is in OKLCH color space, and it will automatically convert between them. And there's also getting pixels back again, so you can read the pixel data you just wrote, and this will return like the byte representation. And then there's also to get the approximate color back, which is as sRGB. And we'll so obviously do color-based conversions. I think they mentioned it down here, saying that it's not exactly the same color that you wrote, because it will convert between color spaces, so you can end up with slightly different stuff. So another thing that's going to be great for editors is that Bevy now has raycast picking and stuff like so, or like picking and selection, entity picking and selecting. So this is like if you had a 3D game with both meshes and you wanted to be able to select something in the world to interact with it, you can enable Bevy's raycasting to meshes, and it'll allow you to do it. They're also doing it for touch screens, so for mouse, touch screens, and pen devices. And then it says each pointing device, humans are come equipped with 10, referring to 10 fingers, get their own screen space. So what this means is that you can basically write like an app that uses a touch screen and can track more than one finger touch at a time, and each finger will have its own coordinate space that allows you to do really interesting interactions. And they talk about like each backend. So each backend domain performs specific work like raycasting. So basically each domain, so mouse clicks, touch, and pen all do their own handling of how they work out what you're actually hitting. And they talk about third-party plugins being able to potentially, like Bevy Rapier and Avion, which are two really popular physics engines in Bevy, will be able to do their own raycasting to optimize things, whereas Bevy turns its raycasting off for meshes by default because it is so performant to try and raycast every mesh. But at the moment, there's still the legacy the legacy style of interaction, but there's also the do picking interaction, so you can use both. And then sprite picking, it does its thing. So the main thing is that they're saying that each has slightly different drawbacks. One being like sprite picking uses the full rectangle, so you can't click outside of a circle because it actually draws a square, and that's how it knows if it's clicked, is if you clicked within the bounding box of that circle, which means that you can't click past a circle, it will still hit the circle. And meshes being terribly unperformant, and then this one just being like this legacy one and a new one, which means that you'll get slightly different behaviors depending on which one you're using. So to use it, it's really quite straightforward and simple. I couldn't work it out on stream when I was trying to do it, but you basically get a pointer, and then like you can say like pointer click, which is every time a click happens, a specific pointer. In the case I was using a mouse, so every time I clicked, the mouse would fire a click event, and then there's also like drag events, and then Bevy's triggers all work with this because they're all just event systems, so it's all nicely tied together. So bubbling observers is an interesting change. So in Bevy, they added observers, which are like things that trigger on events when like a specific event fires. And they're talking about when you do certain types of interactions, say like clicking on a UI element, you may want the UI to bubble up to its parent that it's also been clicked on. I think the example they use is if you click on a person, like a unit in a game, they may be made up of multiple entities, and you want to select the root entity when it's clicked on, not the parent. Like you want to select the parent entity, not the specific entity that you clicked on. So if you click on a person's sword, which is its own entity, it will bubble that click up onto the body, and then onto potentially like a root entity that actually contains the logic. So you can do all that, and you can write your own custom observers, which is like, so auto propagate is just a constant field. So this, I think, determines like without anything being set whether it will try and propagate up. And then there's the traversal, which in this case is the default to the parent, which has its own traversal logic. But you can also write custom logic. So if you wanted to have, say, like a particular entity in the world that collected all mouse clicks, not just the clicks on itself, or like all UI elements send the click to a specific thing that tells like where on the UI you clicked or something, you can have like a custom traversal written. Or I guess like if you had like a unit in a RTS style game, you could have every unit when it clicked on bubble up to its entire squadron being selected using a different like entity that's not actually like the parent of the individual units, but instead the like its own custom logic for selecting. Virtual geometry improvements. This was something that meshlets. So I believe meshlets, from my understanding, are like in Unreal 5, how like they break the mesh down, like really complex meshes down into smaller meshes that can all then be rendered at dynamic levels of detail and have different interactions. And so they've just rewritten a lot of this, so it's all supposed to be like baked at compile time or like during development. And they're just saying that you need to you really need to rebake it for 0.15 because it won't work, and also it won't work on older GPUs anymore because they've started using a specific shader function that isn't necessarily available on older GPUs. But apparently I got more details about that in the migration guide, so I guess we'll go over that in the migration guide video. This video is already going to be long enough. So animation masks is that you can now set custom animation masks. So in this particular video, they're animating the head and the body as two separate animations, and the way you can interact with it is like you can set different graphs and which animation gets to play on which particular part and blend them together at certain ratios. It's pretty cool. Generalized animations. So what they've done is you can now create custom animations in code. So in this particular case, they're calling animate field on text font size, and then they provide a tweening curve to scale the text, and this allows you to do things like animations without needing to actually write animation. So that's what this animation does, is it just scales the font size up and down. And there's some really cool logic that you can create. You can write custom ones if you wanted to, or you can just animate any field. So in this particular case, they're saying like transform translation. And so in this case, and then you can do it ease and curve and have it do all sorts of different like logic and write custom animations in code, which will be really cool for like UI and stuff like that, where like hovering over things can play different curves and stuff without having to like make animations. You can like animate things in code. Animation graph blending is like what they're talking about up here, where they've got two animations playing on top of each other. They added a new node being the add mode, so the walk and run are blended together, and then the swinging animation is purely added on top rather than trying to blend or do any kind of other logic. And yes, it's just lots of animation stuff. I can never work animations out in Bevy. Like it's a really complicated system, but it's kind of cool. There's also like animation events. So that's, in this case, they're saying add an event at 1.5 seconds in, play a sound, and this will cause a event to be fired that you can then catch with a trigger and play a specific event on the entity, allowing for specific points in an animation to be declared like footsteps. So every time the foot touches the ground, triggers the play footstep sound. And then the other example they gave is you can also cause it to be on specific parts. So when they touch the ground, so left foot, right foot touches the ground, you can have an animation play. So you can have like particle effects when it touches the ground. And this is all driven by the animations. You don't have to like custom write specific timings or anything. You can just, I'm assuming events are coded into the animation. I'm not entirely sure how this works. Again, so I don't have enough of an understanding of animations, but I'm assuming inside the animation clip is encoded that the left foot and the right foot touch the ground. And then obviously touching ground is the event that's triggering. And so you can custom write code that like is tied to the animation, which means if you change the length of the animation and stuff, you don't have to worry about changing your timing or anything like that. It's kind of cool. Onto another amazing editor change. This is the Bevy Remote Protocol. So they're talking about you can do all sorts of things from like a different application that remotely talks to your running Bevy application, as opposed to like trying to like hook in specific debugging code, or like having your editor specifically tied to your game, so that if your game is running really slow, your editor is also running really slow because it's like the same application. Instead, you can have a completely independent editor and connect to a game. In this particular example, they give a HTTP style, so you can send a GET request for a entity and then pass in, transform, and then it replies with that. Here's the result of what you just said, and it's pretty cool. So the things that they've got is they get the serialized value for a set of components for an entity, perform a query for all entities matching a set component, and then retrieve the matching values, create new entities with a given set of components, give a specific entity or insert and remove particular components, despawn an entity, represent one or more entities, reparent one or more entities. Oh, sorry, I can't read today. List the components registered in the ECS and present on any entity. Okay. So onto another kind of just sort of quality of life change that like Bevy's been working towards slowly over just changing things that were, I guess, originally implemented by Cart way back when, and just sort of sat around for ages because it was like the way to do them. So gamepads are now entities in the world. So the first thing that they did with this was windows, where it used to be that you had a resource primary window and you would be able to interact with things. And then they decided, but what if we want to be able to have multiple windows? And so they made Windows entities. So now you like query for primary window and then get that specific entity. They're doing the same thing with gamepads. Gamepads used to be a resource of all the gamepads that were plugged in, and then you needed to go to inputs and query for a specific gamepad to have specifically pressed a specific button. Now gamepads are entities, so you can query for all the gamepads that it's detected, and then you can just ask that gamepad, have you just pressed this button? Is this trigger moved? Rather than having to iterate through a list of gamepads and try and work out like which gamepads have pressed this, which buttons. Like, it's much more refined. A query for a single component that has all the functionality, rather than querying for 4 different resources and iterating through one of the resources to query the other resources if they have that specific thing. Button shadows are now just a thing, so you can just attach a box shadow onto a UI node, and it will automatically generate a shadow in the background, and some parameters such as the color, the offset, the spread radius, which I believe is how far out it must go, and the blur radius, which is, you know, how blurry it is, high blur radius, low blur. So that's kind of cool. Cosmic text. So Bevy's moved away from the original library they're using, AB graph or glyph as the rendering library, and instead moved to cosmic text. Their main reason for stating this is that as Bevy's grown, it's started to move away from specifically being like just English-speaking countries and the Latin alphabet, which is what AB glyph was good for. And cosmic text allows them to render right to left, add ligmens, which if you watch my videos recently, is something I put a video out about, saying that ligmens are a kind of cool little thing. So you can do font shadowing, font shaping, system font loading, which means that you'll be able to load like the default font on their computer, not relying on necessarily providing a font that you ship. This isn't actually implemented yet. They do mention later that they haven't specifically added that. Bidirectional text, allowing for left to right and right to left texts. And text editing, which I think they also haven't taken advantage of yet, which is that Cosmic has its own sort of way of editing text. And they've got some nice examples. So that's kind of like really cool that they can like write languages that may not otherwise be representable with the library they were using. UI scaling, UI scrolling, I'm sorry. You can tell there's too much reading in this. So in Bevy 0.15, they've added UI scrolling, so you can specify that the overflow of a UI element is now scroll, and then that if there's a scroll position component, you can modify that scroll position in order to move the like content of the entity around. So you could have like an image that doesn't quite fit inside the viewing container, and then you can scroll around to different parts of the image, or you could have like a list of things that when the list is too long, goes off the bottom, and then when you scroll, you know, more things come up. Like basically like UI elements. There's nothing built into Bevy at the moment that actually uses the scroll, but it is now possible to like do scrolling if you actually want. There's no default widgets, is what I'm trying to say. But things like the editors and stuff will be able to use the scrolling stuff. So retained rendering world, I mentioned this right at the beginning of the video, is that they've changed it from the way Bevy worked prior to this version was every single frame, Bevy would delete its entire rendering world and then copy across the logic world into the rendering world, like copying obviously only the components required for rendering, so mesh handles and all that kind of stuff. And this allowed them to keep a perfect sync between the logic world and the actual world being rendered, but did have the limitation of it was quite expensive to delete and spawn thousands of entities, and like the more entities you spawned in, the slower it would get, because Bevy has like a finite number of entities it can spawn in a single frame before it starts to slow down below 60 FPS. A great example of where this is just amazing is in my voxel game engine that I've been just messing around with on stream. There was a point where I was just rendering out as far as I could to just see what what limitations, and I was still getting 60 FPS when rendering like thousands upon thousands of voxels. Mostly like, and really unoptimized meshes as well. They were just, every voxel was made up of each face of the voxel was made up of 4 vertexes rendering a square. Only like backface culling was implemented and chunking, and I could spawn like tens of thousands of chunks and still be running at 60 FPS because it only updates the rendering world when they change rather than every single frame like they did in previous versions. So it's amazing how many entities you can spawn and still get just ridiculous frame rates in Bevy at the moment. Like even with just generating my chunks, which probably wasn't fast, it was still like cracking at 60 FPS. So it's pretty remarkable what change this has made in terms of how many entities you can spawn. There probably will be performance trade-offs if you are like spawning lots of entities every frame, but if you're not modifying the world, like once the world is rendered or loaded in, the rendering code is just amazingly fast now because it doesn't need to keep updating the render world every frame if the render world isn't changing, or if the logic world isn't changing the specific rendered components. So now each component has a new component attached. Each entity has a component called
render world entity, which tells it which entity in the render world it represents, and the render world components have render world entities have the same, that telling them what main world entity they represent. And then there's a sync to world, and that runs. It's just blazingly fast. So great improvement. This is something that they're saying about. It's only sort of a in-betweeny state because of migration hell. So when the next version of Bevy comes out, they will have removed a lot of their hacks that are about just making things work while people migrate across. So they've added curves. So Bevy's added a new curve trait, which allows you to make like animation curves, or like mathematical curve descriptions that have a single value that comes in that maps like one value to another value. So it's like in this case, it's saying that the parameter t allows you to map like through a specific space of time, or like percentage progress, that kind of thing. So it means that you can do things like easing and tweening. And so like in this example, they've got like all the custom built-in ones, or like the built-in easing functions. So like sign in and then sign out, and then sign in and sign out, and all this. And it's like things like elastic in, which is that it's basically small, it wiggles back and forth and then zips up. And then there's elastic out, which does the same thing, but it shoots up and then sort of bounces back in place. And then there's also elastic in, elastic out, which sort of does the same thing on a smaller scale at both ends. And then they're saying that like you can use this with like to like basically animate things. So in this particular case, they're saying rotation curve with a easing curve of the starting from identity and going to half pi. And they're using the elastic in, elastic out, which is that it'll slightly go the wrong direction and then go fast to so you see it goes forward, then a lot backwards, then all the way forward, past where it's supposed to be going, back a little bit, and then back to the right position is what it'll do. And as you can see with this cube, it does a little forward back flip and then tweens back into place. So it's really cool that you can do all this now, like using all these easing functions that Bevy provides as like just curves that can be written. Like say any library could create a set of curves that you can provide a value between 0 and 1 and get out a value that does something. So in this particular case, it's easing between quaternion or identity and the rotation. And it's saying that these new easing traits have been implemented for floats, vec2s, vec3s, vec4s, I'm assuming, directions and rotations. So it's pretty nice. Now they've also got cycloid splines, which is something that I've never touched, but they're saying it could be useful for things like NPC pathfinding or other things in games where like originally you could only make a spline that was sort of like a curve. You couldn't make a spline that looped back to where it started, but now if you used two curves cycle, it'll loop back around to the start. And yeah, I'm sure some people will do some amazing stuff with this. I've definitely seen a few things where like people have done some really cool stuff with curves. Not necessarily in Bevy, but like just as general game development stuff, curves are an amazingly powerful tool. They've now implemented partial reflect. So in Bevy, there's the reflect component, or the reflect trait, that lets you dynamically box up your type and use it as another type, or like store it in like a list where you can have lots of different types that are all stored in the same list because they're using reflect, and you can request specific parts of the data out of them. They're saying that one of the issues that people are running into is that when you're doing something like deserializing or that, you can expect to get a solid trait, but end up with an actual dynamically created trait. So this is like if you, instead of having a like actual Rust compiled trait that is as like a string of bytes that is the right, instead you have a hash map that when you request a specific field, it looks up in the hash map to retrieve the data. And they're saying that sometimes you expect to have a solid trait, like an actual implementation of the trait, because your reflect is telling you that's what it is. But in reality, the underlying data is actually a dynamic type, so like a hash map or something, just linking all the types together, or all the fields together. And so what they've done is they've implemented a new trait, which is partial reflect, which allows for these dynamic traits to be used, whereas reflect now, you can only say that you are the type that you are. You can't claim to be a different type, whereas if you're a partial reflect, you can claim to be a different type if you contain all the data that you want, like if you want to be represented as that type, you can say that you are that type, whereas reflect has to be the type that it says it is. And this should mean that, like, if you're using reflect all over the place, you know that the value when you request is the value that it is. Whereas partial reflect can be used in places like serialization and deserialization, where you don't actually care if the underlying trait is just a representation of the data. You can then like request all the information and convert it. So there's also reflect remote. So this is another one of those implementation details of the Rust orphan rule, where you can't implement reflect onto a trait that you don't own. So if you were trying to, say, use Rapier with Bevy and you're not actually the Rapier crate yourself, you can't implement the reflect on a lot of the components. So you would need to implement stuff like that. And so what the remote reflecting does is it allows you to create like a wrapper and then reflect the specific external crates type. And then when you use this, you can now reflect values that are not owned by your crate. This in this particular example, they talk about how you couldn't use things like anything that didn't implement reflect couldn't then derive reflect. So you'd have to ignore a specific field when you derive reflect. But now you can specify that you want them to treat this field as this remote wrapper when it's reflected, to define specific reflect behavior for something that you yourself can't implement reflect on. So this a nice workaround of the Rust orphan rule to allow you to like implement crates that you don't necessarily own ownership of and aren't necessarily built to be directly integrated with Bevy. And they've also, go along with this, is added the reflectable trait. So in reflect, there's lots of other little sort of sub traits that you need in order to actually reflect something. So when you derive reflect, you also derive path type and typed and get type registry are all like automatically implemented when you derive reflect. And sometimes when you're doing things with reflect, you will run into errors because it'll say like on a generic, for example, you have to specify that the generic is reflect and reflects type and type path and typed and get type. And so they've basically just added a trait that automatically super traits all those into a single trait. So you only have to say my generic type is reflectable, and then all the reflect logic will work. Whereas before you had to say that your generic type was reflect, type path, and lots of other stuff. So they've also added function reflection, which is like kind of cool, but also one of those worrying things about like bypassing Rust's type safety. But the idea being that if you wanted to make like a scriptable language, you would need something like this to be able to allow a person to write a function that you can create at compile time or at runtime, rather than needing to know every possible function signature at compile time. And so this allows you to reflect a function and then pass in the data in this particular case. So push to owned into the argument lists, and then you call the function, and then you can like try take the answer. And this all integrates reflect in such a way that if you get the wrong type back or you request the wrong type, it'll all not work. Which allows you to write basically like functions that are executed at runtime, and all like parameters can be extracted from strings and stuff like that. So you can write dynamic scripting libraries for Rust using Bevy's reflect, and then implement it into your game. So you can have like a little coding language or something, or like a scriptable language. So it's kind of cool. Closures can also be reflected. It talks about like if you want it to be access mutable data. So in this particular case, the function just does calculations, whereas this one actually captures the total mutation, and so would need mutable access to this value. And so you have to use the into function mute, and then you can call this to mutate it each time. So it's kind of interesting. And then they say you have to like drop the function to release the pointer. But they also say you can also call once, which would automatically drop at the end of the thing. So there's also function information, which allows you to like extract information about like what the arguments are and stuff like that. It's all like really cool stuff for if you're doing specific stuff in Bevy. It's not a general use case thing. It's more of a library building thing. Like, again, I've done a lot of serialization where reflect is amazingly powerful, and things like dynamic functions and like reflectable functions will be one of those things where a scriptable language would greatly benefit, but most people are unlikely to implement it themselves. Instead, it's going to be like crates, community made stuff that's going to be amazing to see what they do with it. There's also like manual construction, so you can like in fact build your own dynamic function, as opposed to needing to specifically have the function already be made. You can like build it at compile time. You can build it dynamically at runtime, not compile time. The whole point is runtime stuff. Okay. And then they talk about like a function registry, and it's basically it's reflect but for functions as well. So it's really cool. Limitations being things like their type needs to implement reflect, and reference to a stir doesn't implement reflect, only a reference to a string does, which results in weird borrowing like double references. Also something about like you need to explicitly monomorphize things, which is basically saying you can't call it on a generic, you have to actually provide the generic value and call it from there, which is interesting. So type improvement information, type info improvement. So with reflect, you can request type information is one of the things that like every struct that is reflect has type information and is used to like work out certain logic about converting from one type to another, or like accessing specific information, all that stuff. And they've just improved that. So in this case, like it's you can get generic information now, so you can get type information generics and then like request information about the generics, like what it's called and the type name and stuff like that. So in this case, is F32, is the generic is F32, but the name of the generic is T in this particular struct. Is it constant, which is if you use Rust with the constant generics, you can say like const U64 and then a value and then specify. Like, so when they pass in a call to that particular function, you can like have it custom code in a constant value, and so that's what that's all about. It's kind of cool stuff. They talk about nested type information. So you originally had to do like really fancy stuff about like accessing the underlying type information of like fields. So in this particular case, they're saying like row ID and then usize. It used to be quite difficult to get the type information of the field ID. So in this particular case, we know it's a usize and we could just get type information for usize. But they're saying like now you can say, I want field ID and then I want the type information of that field. And it will automatically work all that out. And they've also added like convenient casts. So the type information would it's encoded in a way of like there's reflect reference and it says like there's a list, there's a map, there's a struct, there's an enum, like all the different types of type information, and you used to have to match into it, like let type equals this to get access to the data, even though you knew what the type was. Like you knew it was a list, you just had to match into a list and return it wasn't a list otherwise. And so they've added like convenient converters that just says as list and it will automatically convert it into a list version of itself. So it just a convenient way of doing this when you already know what the type is, as opposed to like if you were dynamically deserializing something, you may have to match it to try and work out what to do next. This is like, I know what it is, just let me have it. So you can just unwrap stuff. So there's the typed trait, which is again just more reflect stuff about making reflect so much more usable for people. So in this particular case, they're talking about that type in Rust. There's a type ID, which is just a U64 that uniquely represents every type in the in your compiled code. So every time you compile your code, it'll compile into each type, and each type will get a type ID, which is U64, and Rust uses this for its type checking, borrow checking, all that kind of stuff. But you can also use it in your code to be like, are these two types the same type? And then so reflect uses a lot to basically like compare two types and say like, is this reflected value the same as this reflected value? Like, are they the same underlying type? And so what they ran into with a lot of people is that this could be really annoying for debugging purposes, where it's like it works beautifully for like running your code fast, but meant that if you did hit an error and it had to print an error message, it would just print out a random gibberish of numbers because like it's compiled and it's specific to your, I think it's your specific compile run. Like it's like if you recompile it, they may be different. I'm not 100% sure when Rust recalculates type IDs because it might be like a hash or something, like the string paths. But the type IDs are like just IDs. Like they're opaque. You can't tell what the type what type made that type ID. And so they've added a new type called typed, or a type. And this just also contains a pointer to a string that is the type's name. So when you debug print out a type, it'll actually print out the name rather than just the ID. And they're saying at the cost of an extra 32 bytes, which I believe is just the fat pointer to where in memory, maybe even just a regular pointer. I don't remember how many bytes a U64 is. But yeah, the idea being that you can store, like, you can just like use type in a hash map and get the type ID, and it's it opaques down, or like, it's transparent down to type ID. So if you compare two types, it checks the type ID against each other. It hashes the type ID. Par equals type ID. So everything's the same as a type ID. It just, when debugged, will print out the type's name instead of just a gibberish set of numbers. Okay, so Reflect now supports sets, which is, like I was saying before, up here. They had like list, hash map. Now they've got set, which is, you know, like a list where each entry is unique. It's a set. And so things like hash sets will now work. So things like the Bevy the Bevy inspector EGUI can now like make EGUI elements for sets where it couldn't do that before because they weren't Reflect. Okay. Change detection, source location tracking. This is another like change that they've added for the sake of like debugging. So what this allows you to do is enable the feature track change detection, and then on every time you get a mute or a res, right, which is the way that Bevy allows you to get access to data. So when you do a query, you'll get references and mutes, and your type's actually wrapped around in that, which is how Bevy can do change detection. So you can say like is changed and stuff like that, is that they're actually wrapped in a type that keeps track of when they were changed. And with this tracking enabled, it'll also keep track of the exact line in code that they were changed. So if for some reason you're trying to work out exactly where in your game something is changing, you can say my component, or like get access to the information, and you go change by, and it'll tell you exactly where in your code that value was changed. And so this is like great for debugging, as I said, but it's hidden behind a feature wall because it's immensely unperformant to keep a copy of exactly where in memory every single time something's changed, because like transforms are changed hundreds of times by like all sorts of different systems. And so it's a like turn on for debugging, track down exactly where it's happening, that kind of thing. It's cool change, gonna help like big production games or like small indie developers trying to find a specific bug. So they've optimized iterators for mixed set, sparse set and table components, which is when you call like a query on something, most components will be table style components, which is that they are stored in a table really densely packed so that like every entity is expected to have one. So basically each entity just points to a specific point in the table, like that is their entity ID, versus a sparse set where you have like a hash map that you pass in the entry and it goes and finds the specific data. And what was happening with Bevy is that there was a bug that meant that if you had a sparse set and a table, it would use a really slow algorithm to look up like the data. It couldn't quickly access it. And they're saying you got like a 1.8 to 3.5 times speed up by fixing this little bug that means that like it can use the more optimized algorithm. I think they talk about zero typed, which is the idea that if you are querying for like a specific component that has no data, it won't slow down the iteration of the table lookups, because table lookups are much faster than sparse sets. And so if you're got a zero typed component or something that is sparsely set, it will just ignore it and use the faster algorithm of using the table lookups. So it's a cool improvement for like micro optimization, but I think what they're saying is most people wouldn't have noticed the difference because the algorithm wasn't running, but now there are like a certain niche cases where it'll be immensely sped up. Okay, monitor handles. Expose Winnet monitor handles. So there's something about the way that Bevy handles monitors means that like they you weren't before this able to access the actual monitor information about like resolution and refresh rate and all that without doing some convoluted loops accessing specific resources about WinIt and like requesting that kind of information. So instead, Bevy's exported this out as a monitor handle. And so you can query for the entity with the monitor, and you can then like spawn additional windows and stuff like that on a specific monitor, and you can request like its refresh rate or its resolution and change behavior based on that. So some cool stuff for like really interesting games. Like I could think of like there's been some games that have come out, not necessarily in Bevy, but like just like use that really interesting approach of like the game doesn't have tabs, it's all different windows, or like the idea is like it's sort of got to manage your monitor space because each window is around. This would allow you to work out the resolution of the window so you can make specific smaller windows take up like 10% of the screen rather than having like people with big monitors have an advantage because they can see everything at once. You could specifically code into your game that this particular panel takes up a certain percentage of the screen. And a lot of the time games that were doing this didn't use your real screen. They would make a desktop inside the game, whereas now you could actually make a game that uses the real user's screen as an input. So custom cursors, this is a cool change. Oh, I've opened something up and closed it. So Bevy apparently used to let you use the built-in cursors, so you could say like, use the loading cursor or use the grabbing cursor or the clicking cursor. And now you can write completely custom cursors. So you can like provide an asset. I don't know what hotspot is, but I'm assuming that's area where the click actually happens on the key, like on the image. But basically you can pass in a cursor icon and have like a custom like cursor. It also mentions that it's handled by the OS. Like it's obviously like an OS function that they're tying into, which means that if your game freezes, it won't cause the mouse to stop. Like the mouse will still work exactly the same because it's actually loading the application into the OS and running the mouse that way. So it's cool. It'd be interesting to see if anyone actually makes anything out of this. I think it's one of those, you wouldn't notice it, but it's amazing that it's available for people to mess around with it easy. So you can now uniformly sample meshes. So this is that basically you can get a mesh, get its triangles, and then get Bevy to like sample the edges of the triangle. So like if you had a procedurally generated terrain, you could get it to sample 1,000 random places and put rocks there. Like it lets you actually sample the surface of the mesh to place certain things like terrain and stuff like that. So it's kind of just an interesting niche thing for procedural generation. I'm looking forward to playing with this in my dinosaur game or something like that, where like you want to split like trees or grass or something, where it's sampling a particular mesh. So it'd be interesting. An event mutator. So this is another interesting thing where like I never really considered it, but apparently this is a thing that people wanted, and that you had to do really convoluted to do before. The idea being that if you are like iterating through events, so like mouse movement events, you may at some point want to modify the event without necessarily re-emitting the event, so that future things to consume the event will get your new modified version. So like you might have a system that says, oh, this event, I've consumed it, I'm going to like say that it's been consumed by this or like consumed by that. So you used to be able to do this like by accessing the underlying event struct, so like the res mute events, and then the event cursor here. So and then you could access it and then mutate the specific event. But now there's an event mutator, which is basically an event reader that keeps track of all the bookkeeping for you and allows you to modify events after they've been fired. So if your system catches them and say like runs in the last frame, it can modify them before the systems that run in the beginning of the next frame get to use them. So it's cool. I don't really know where you'd use this, but it's interesting that they've added it, and it's like an interesting like concept of like having events be modified as they're moving through the state. So isometry types, which is apparently basically a reduced transform. So the idea is that a symmetry type doesn't have a scale and is always represented as a rotation followed by a transform when you're applying the logic. So when you multiply them together, it's always a rotation scale, and then I guess rotation scale when you multiply two together. Not entirely sure, but they're basically refined transforms to make mathematically moving things around in and conversions between local and global space easier, because you don't have to worry about things getting scaled, like rotating something and then scaling it or multiplying it by a scaled value. So they're all basically a uniform scale. They transform with a scale of 1. They're used in things like gizmos and stuff like that, and yeah, just fancy math basically. So it'd be interesting. Yeah, you can convert transforms and global transforms to isometry 3Ds using the isometry function. So the lifecycle hooks, they've added a trigger for replacing. So in the last version of Bevy, they added a bunch of hooks into the game, which means that basically when you add a component, when you insert a component, or when you remove a component, you could have very custom pieces of code run. So register hooks, so hook.onInsert, run this code, on removal, run this code, and this would run specific code based on like the value of the when it's removed. So you could use it for like bookkeeping, that like whenever you insert a specific value, it adds it to a list, and then when you remove that component, it removes it from a list, that kind of thing. They're basically saying that add and remove are the polar opposites of each other, but onInsert didn't have an opposite, which resulted in sometimes your bookkeeping could end up out of whack, because if you added an item, added a component, it would run the onAdd, but if you then inserted a component, it would run the onInsert, but it wouldn't run the onRemove because you never actually removed the component. So they've now added an onReplace, which is if you insert a second copy of data that's already there, the onReplace will run on the removed data. So it's basically remove when the component still exists at the end. Hence, if you add, the opposite is remove. When you insert, the opposite is replace. So when you insert data, the data that came out will run on replace if there was data there to begin with. So here's another just performance improvement. So they're now packing vertexes and indices together in a growable buffer rather than having each individual like mesh have its own buffer, I guess. It's just like a performance improvement thing. They're saying that they get about a 2 times speed up from doing it this way. So it's pretty impressive. It's probably another reason that my voxel game runs so incredibly well. So just lots of fun stuff for people that are running Bevy to its limits. Get just huge performance improvements with basically having to do nothing. So they've rewritten how screenshots work. So originally Bevy's built-in screenshot system could only target a specific window, I guess. So you could only screenshot a window. But now the screenshotting can target anything that can be a render target. So if you were rendering a specific camera to a certain texture that was then rendered onto to the screen, you could then screenshot that texture rather than having to screenshot the whole screen. So like screenshot primary window as set a disk path. Okay, and then render target. So basically anything that you can render the camera to, you can now screenshot that specific rendering rather than just the screen. So again, it's just another thing of like very niche use case where is someone specifically using something. I think they said that the main thing that screenshots would be used for is like tests and like unit tests like that. So if you want to make sure that Bevy's rendering the same every time, you could have it screenshot and then compare the screenshot to the last time it ran screenshot. Now you can do it to like sub render, like render it to a specific target or render a specific thing. So it's kind of cool that like Bevy's giving you more control over that, like because it doesn't make sense that just render target just the screen or just a window would be targetable. Now you can target a specific image. So it's kind of cool. Anyway, system parameter builder. This is again like another great thing for scripting, is this was allowing you to build systems at dynamically at runtime, and so they've just expanded this to use a system parameter builder instead of just a system parameter. And then there's some rules about entity mutation. So in Bevy there is an entity mute and a entity ref, which allows you to access the underlying components of an entity without necessarily having to query specifically for certain components. So you could have a query that requests the transform and the entity, and then check the transform, work out if you actually want to access something else in the entity, or look at what else the entity has based on certain logic, and then do that. And they've basically added a filtered version of this, which allows for I'm sure there was more examples. So it allows you to like accept, which gets around Rust's borrow, mutable access borrowing and stuff like that. So basically, before you couldn't borrow a entity mute and an animation player because that would theoretically allow you to edit the animation player through the mutable reference. So now you can say entity player accept animation player, which basically says to Rust, hey, I'm not going to access this because it's physically not accessible. And so you can have an immutable reference to it while you have a immutable reference to everything else on the entity. So they have done some pretty cool stuff with that. There's so state scoped events. So very much similar to how Bevy had like state scoped resources, or I think it was state scoped entities, where when you left a state, the entity would be removed. Now you can do the same thing with events, where if the events haven't finished being consumed when the state changes, they'll be cleared. And so like an event can only be fired while the game is running. It can't be fired from the main menu, that kind of thing. So again, it's sort of a expanding the Bevy toolkit to be more universal across everything. So it's kind of fun. So cached one-shot system. So the way that Bevy's did its systems is you could run a one-shot system and then you could run it again and it would not have any local data. So because like each individual system that you ran would then would be considered its own instance. Whereas now you can run cached, which means that it actually, I think, uses the pointer ID as like the way that the data is saved. So if you're running exactly the same function again, it can use local data and it'll actually retain the local data or the query cache and stuff like that. All the optimizations and performance benefits that Bevy can provide, you'll get because it'll keep it cached. It's also the same here that you can register a system and then register the same system again, and then you will actually have two separate systems that, depending on if you run one or run two, you will get different results because they're technically two different systems that keep their own local state. But now you can register them cached, which means that if you're registering exactly the same function twice, it'll actually return the same ID, which means that running them, either one of them will result in the same result, which could be useful depending on what you're trying to do. So I believe, from what I understand, that the uncached version still exists, so you can still have multiple copies of like a specific system that you run, but you can also use the cached version if you actually want to only run with the one local copy of variables. So there's the one limitation that it says something about you can't have more than one type if the size is equal to 0, which is like a very niche case, and they have the compiler won't let you compile if this is true. I believe this would be a result of if you called like a generic function, it would it could be different depending on what the generic is or something, size of S. So like this is true. So it's just it's a very edge case that the compiler will tell you about if you ever hit, I believe. So they've changed system parameters to no longer be panics, which is kind of nice. It annoys me because it means I'll compile something and it'll be like, why is it not working? Because I didn't look at the console, where the console now spits out saying, hey, this resource doesn't exist, so this system didn't run. So in Bevy 0.14 and prior, like if you didn't instantiate a resource, or if you requested a specific query for something that didn't work, it would fail. Now, I guess it's only resources, isn't it? Now Bevy will put out in the console and it'll spit out an error message saying, hey, this resource is not initialized. So that's kind of cool. This run conditions will be skipped and return false. So basically, if a run condition tries to access a piece of information that doesn't exist, Bevy just won't check that run condition. It'll just say, nope, you don't get to run because we couldn't check whether you were allowed to run or not. And prints an error message saying it did that. And apparently also pipe gets skipped. That's interesting. Never parameter one. Okay. So passing data into systems by reference. So in 0.14, they added the ability to like run one-shot systems that actually return data back out. So if you have access to the world, you can like run a system and it will actually return a value back out. And they're saying that the issue is that you could only pass in things that had a lifetime that lasted as long as the first parameter, I believe it was. There's a limitation. Maybe is it can only pass in things with static lifetimes. But basically, as they said, using some type magic dust, they've removed that limitation, and you can now pass in references that will then, when the system runs, do whatever they want to do, and you can keep your reference, which is going to be great for very niche cases. Again, like a lot of this stuff is like amazing for people that making like really complicated libraries as opposed to specific games, but also like very specific like implementations of certain features that you may want in your game. They're just removing a lot of restrictions that Rust would otherwise imply on you because of its type checking and stuff like that. List components, query interior, query does not match. Right, so what this is when you requested a specific entity from a query, if the query didn't exist, it would spit back saying, hey, like this entity is not in here. But now it will actually, when you print that out, tell you what components are present on the entity so that it's much easier to like debug why a component's not running. Like you can sort of see what else is there, which I think goes hand in hand with the required components in that you can like assume that a component, if it has this, will have that. And you can now see, because it'll tell you, like these are what it does have. And you can be like, oh, so something's not got a correct requirement, that kind of thing. So it's just, again, it's more easy debugging. That's like a common trend with this is it's editor changes and really nice debugging stuff. Okay. So apparently, I had no idea about this, but Bevy is adding no STD progress. So at the moment, they're just adding linting, which is going to be going through and checking, you know, like, hey, why are you using STD instead of core? And allowing them to like slowly progress towards making it so that Bevy will be able to run on embedded software. So like my dream of a Pico running Bevy may actually become a reality. I've been wanting to do that for ages because I think Bevy would be a great like top layer real-time operating system style like approach of being able to write like a Bevy application and have it compile onto a Pico, because it's going to run every frame. It's going to do all this update. Like it would be just, it's like a great architecture for building a like real-time operating system would be Bevy, as just a way of laying out how systems all function together and requesting certain resources and memory management all done by Bevy. I've wanted it for ages, but like I tried compiling it for a Raspberry Pi once. It did not go well. So it's good to see that they're making progress towards a no STD version of Bevy to allow for some cool stuff like that to happen. I'm going to ignore the GLTF stuff because you know, I don't like GLTF. They've added material names. I'm just, yeah, cool. There's GPU readback, which is now the ability to add like a readback buffer so that you can more easily get data back from a shader. So if you're using like a compute shader, I believe is where this would become the handle, you can read back parts of the buffer and do some cool stuff like that. Again, I really haven't used shaders much in Bevy because I'm just too small brained for it. But anyway, so Android has changed to a configurable game activity instead of native activity, which I don't know much about Android, but I believe like game activity would be treated separately by the operating system than native activity, where certain like behaviors may be treated separately when they're in a game state rather than a native state. And then basically by default it'll be game activity, and if you want to replace it, you can go in and set a feature flag for it to be native activity. So yeah, more modern Android stack. Okay. Reflection serialization improvements. So again, as someone who's tried to implement something like a serialization engine using Reflect, it's not actually that bad. Like Reflect is amazing for doing it. It's just one of those. That's what they're addressing here, is that you can end up in a situation where you have to keep passing the repository, the type registry around, because like when you want to do custom deserialization code, you have to build your own custom deserializer, and then you may want to then use Reflect deserialize for sub parts of your custom serialization. So you needed to be able to pass the type registry in and have to clone it all over the place. And it could get out of hand, but it was amazingly powerful when you got it working. And so what they've done is they've added 2 new types, which is serialize with registry and deserialize with registry, which just allows you to implement your serialization code automatically taking in a type registry rather than having to specifically write custom types that then require the registry. So it much more easily passed up and down the chain as a reference rather than as like you having to clone and pass, keep a copy of the arc itself. I'm just gonna skip over the serialization processes because it's a bit complicated. Simplified multi-entity access. When using some of the more advanced features of Bevy's ECS, like hooks or accessories, it's common to want to fetch entities straight from the world. Okay, yeah, I could see that being a use case. Component add. So in previous versions of Bevy, you could grab mutable entries from the world using a variety of different functions, right? Okay, and as you can see, there's a lot of functions with very long names, but the gist of this is that if you wanted to support the ability to give a batch of entity IDs and retrieve a batch of entity references, so there's a better way. So get entity mute, okay, entity ref, entity, but now you can just pass in an array of IDs. Okay. So what they've changed is that instead of having custom functions for getting entities from the world, it's all one function that obviously implements trait and like monomorphizes itself into whatever type implementation it needs to be able to get access to multiple entities at a single time while maintaining Rust's strong mutability access. So hierarchy traversal tools. So full set of methods is now, so basically in 0.14, I think they added the functionality, it might have been earlier, that if you have a query that is just a reference to parents or a query that's just a reference to children, you could iterate through the hierarchy. So you could say iterate descendants if you had one that contained children, and you could iterate ancestors if you had a query that contained parent. And they're saying that now they've added the ability to grab just the parent, just the children, to grab the root ancestor, which is if you iterated through all the ancestors and found the one that doesn't have a parent. Iterate leaves, which I believe is to go down to the lowest leg of each possible branch. So basically start at the root and go down, and anywhere there's a branch, you keep going until we find a child of the root that, or subsequent child that doesn't have a child node, is a leaf node, and then iterate siblings, which I believe would be to go up one in the hierarchy, so go up to the parent and then iterate through its children, and then iterate descendants depth first, which I guess would be find the root, go all the way to the bottom, and the one that's the furthest from the root, iterate through those, and then step up one, iterate through those, step up one, iterate through those. Say storage buffer assets. Again, don't understand storage buffers enough to talk about this, but I'm guessing this is going to make shaders more powerful, and probably compute shaders are like a whole lot more powerful, because it's going to make it easier to get information in and out. Accumulated mouse input. So this is something, again, if you watch my streams, you would have seen me do, is that I keep implementing fly cameras, and a fly camera has the thing that you need to collect all of the mouse movements, but because of how Bevy accesses the operating system's mouse inputs, it will require you to like basically iterate through all the events and collect them into a single delta and then use that delta. So now Bevy has a resource, accumulated mouse movement, which is that Bevy, like probably in the first function, will iterate through all those events, collect them all into a singular resource, and then you can access that resource for later consumption. So rather than having to compute it in all your places, Bevy will do it once at the beginning, and you can then access it from there. So stable interpolation and smooth following is kind of a cool thing of allowing cameras to follow programming, that follows like tweening and stuff like that. So it allows you to like smoothly move the camera around without it having to like worry and jitter. So it's saying like moving something continuously towards a target is essentially basic operations, and simply lerping from the target is easy enough. But making sure that the interpolation is time step independent is both vital and surprisingly tricky. So they're basically saying that you can use the stable interpolate trait with smooth interpolate or interpolate stable and smooth nudge methods to tune the decay rate to basically allow you to make much more smoothly cameras that follow the player around. So that's kind of like a cool usability thing that's implemented, like basically Bevy's done all the heavy math and worked out a library and included as part of it. Finally made it to the end of the video. God damn, this video is long. As I said, 0.15, massive update. So we're up to the final section. What's next? So Bevy scene notation. So basically they're planning on adding a something scenes. Yeah, so a specific Bevy specific file format compatible with complete with macros and IDE support, so that you can write a Bevy scene and have it be like auto checked and go like, yes, that's a real component that you can use. Like it'll be goddamn amazing that Bevy will have like scenes that you can edit with the editor, with the IDE and stuff. It's going to be great. So better font support because they've swapped to Cosmic Text. They're basically going to do a heap of work on improving different text rendering and all that, like just basically integrating all the features of Cosmic Text into Bevy. So they're going to swap over to the picking powered UI interaction. So at the moment, there's still the legacy code that exists, but I'm assuming they're going to get rid of that. The Bevy lint. So try as we might, it is possible to misuse Bevy's API, and so they're adding a Bevy Bevy like lint or Bevy CLI project. So basically, it'll have a linter that, like Clippy, tells you when you're doing something wrong, but specifically programmed for Bevy. So it'll say, hey, like you're doing this wrong. Somebody in my stream chat said that they were planning on adding something that I'd come across, because I was adding a integer to a vec3 instead of adding the vec3 multiple of that integer. So my camera, when I was flying around, if I pressed up or down, would move diagonally because it was just adding the up value. It wasn't adding a y vector of up value. And so they're saying that they'll add things like that into the linter, so that when you are adding like when you do like complex multiplications of vectors, you can have the linter tell you that, hey, like the order of those operations is ambiguous and may not actually be what you intend to do. So it'll be interesting to see how this turns out as Bevy adds more like cool little things of being like, hey, this is not the correct way to do this, or hey, there's a better function for that, because they're basically going to look for common things that people write that can be improved. It's kind of cool. Okay. Focus abstractions, which is keep track of the UI element in focus. I think this is about making like UIs more easily like navigatable with gamepads and stuff like that. Or this is picking. Yeah, so it's gonna like, it's how different elements of the UI are focusable. So it's kind of cool. Immutable components. Component hooks and observers are really powerful to changes. Okay, so basically this is like components that I believe is like you add them once. Operator direct mutability. Oh, okay. So this is things like how when you set a parent, you need to make sure that you update the hierarchy so that if I update something's parent, I need to tell that parent that it has this as a child. Or if I remove something's parent, I need to go up and tell that parent that this is no longer its child, and like all that kind of thing. Or if I add something as a child, I need to go down to that child and add it as the parent. So this is basically saying that even though Bevy has functionality to allow you to too far. Even though Bevy like has functionality to allow you to hook into that so that when a parent is added, you can then go and get the child, that kind of thing. They're saying, like, you could theoretically just go in and change the parent manually without adding a parent component, and that may not trigger the correct thing. So they're adding the ability to say that only these functions are allowed to modify that specific component, so that things like your bookkeeping can't get out of whack because someone's mutating something when they're not supposed to be touching it. Same as like computed visibility, where it's like only Bevy's supposed to be calculating the computed visibility. So you would want to make it immutable so that nobody else can touch it except Bevy, and then like a lot more logic can be sound of knowing like it's calculated correctly. So they're talking about actual retained rendering, which is that the rendering is technically retained, but most of our code still spawns and despawns entities every frame to reduce the risk of integration bugs. So basically, they haven't got 100% there, but they're planning to move the needle further, and then no SDG Bevy to better support wider platforms. So a lot to come. I hope appreciate anyone that made it to the end of this video. My voice is gonna fucking die now because it's been an hour and a half of constant talking. I'd like to thank Cart for fucking making this amazing game engine to begin with. Fucking boosted my YouTube channel into actually existing. And I'd like to thank all the people that have contributed to Bevy, because it's amazing to see how much this game engine is growing. It's a little weird to have people come into my Discord and tell me how like they don't like that Bevy's changing all the time, but to me, like, I hope Bevy doesn't hit 0.1, because the amount of really amazing stuff that gets added to Bevy, like sometimes shit changes that like doesn't make sense. Like they renamed delta seconds to delta secs. Apparently it's to more align with the naming scheme of the standard library, but it does lead to certain issues where it's like, well, why did they change the name? Like, why do names change all the time? But like Bevy is growing as a community, and it's amazing to see what people do, and I hope to keep making videos about it because it's such a cool little project, and hopefully I'll manage to make a game, and I'll subscribe to the channel. I'll see you in the next episode. I think I'm going to do a Bevy basics on either hooks or the life cycle, or there was something else. I think of observers. Like going through this change thing is like opened my eyes to a whole bunch of shit in Bevy that I didn't know existed. So I hope that you all have enjoyed, and I will see you in one of those videos.